One of the challenges we consistently hear from our clients is the difficulty they have getting real-time ERP data into their analytics platform. For many, ERP is an independent system, beloved by finance, critical to business operations, and something which must not be tinkered with. It has to be treated with kid gloves, and is often the last system to be migrated to the cloud and integrated with others. The cost and complexity of migrating ERP systems can be daunting. As many as 75% of projects fail, and 45% of the successful projects run over budget. We set out to use Fivetran and other modern data tools to solve this problem. Our aim is to show that ERP data can be made available to the business quickly and easily with a minimal investment. We believe with this approach, enterprises can combine ERP data with other data sources to create a complete view of their business, and that's a powerful competitive advantage. You've probably worked out from the opening of this video that one of our favourite movie series of the 90s and the noughties was The Matrix. If you've seen it, you may recall that Morpheus gives Neo a choice between a blue pill and a red pill. The blue pill, if he took it, would take him back to his old life of ignorant bliss. But if he took the red pill, he'd wake up to a new reality. We applied that analogy throughout this project. The blue pill represents the old way, when ERP systems were your data strategy. All the company's data locked into closed, proprietary systems that were then heavily customized to suit your specific operation through years or even decades of development. The red pill illustrates the new way, where an ecosystem of modern data tools allows data to flow across multiple systems in real time, leading to fast innovation and lower cost. You could argue that without this new way, we wouldn't be seeing the acceleration in AI that is happening all around us. Neither approach is wrong, but the tools, skills, and knowledge to build, develop, and maintain each system have developed independently of each other. And that creates not only a technology divide, but a cultural one too. And that is problematic. In a study commissioned by Fivetran, it was identified that 82% of ERP data was stale when it landed in a report or in a dashboard. Not surprising when we're hearing scenarios of 1 million rows taking over 9 minutes to load. In a report with over 100 million rows, that adds up to, well, too long. What's worse though, is that business leaders are making decisions on this data. Good decisions on bad data are still bad decisions. IBM estimate the cost of these bad decisions to be $3.1 trillion per year. That's the value of the AI darling NVIDIA. This is all compounded by the difficulty of getting data out of ERP systems and into analytics platforms that are built for scale and speed. Over 2/3 of respondents think that ERP vendors make it deliberately difficult to move their data. Let's take a deep dive into our solution to this problem. We've used Fivetran to connect to a typical SAP ERP procurement system. We start by taking a look at how an SAP user will find, view, and edit purchase data before creating a new PO from the same system. We use Fivetran to load data into Azure Databricks, where we use Prophecy to transform it through bronze, silver, and gold layers for presentation in a Sigma dashboard that shows Fivetran CDC capability, making updates in near real time. Important to note is that all of this happens transparently to the SAP user's experience, and there is no change to their working practices. We leverage the processing power of Databricks to ensure there is no additional load on the ERP instance. Unless you're familiar with SAP, it can be complicated to understand what's going on. Part of that complexity comes from the way SAP stores all its metadata in technical abbreviated formats. That makes it difficult for data teams to perform analytics and get insights out. We're going to use an old order as our reference, selecting the one ending 048. You can see the details in the title bar. This is a standard purchase order, 048, created by user S4ABAP1. Here the supplier is 24test with an item bell_mat04, quantity 1, price at €100. The purchase order gets recorded in the EKKO table, purchasing document header. You can see order 045 is the purchase order recorded before. Opening the same purchase order from the EKPO, purchasing document item, table shows the item details in this, matching as bell_mat04, quantity 1, price €100. The most recent purchase order in the system ends 160. We'll create the next purchase order in the sequence for the remainder of this demonstration. Now, let's add a new purchase order. Same organization, ZBE1. We'll add a material, test BE procurement. The order is created and may take a little time to process. Here it is, a new purchase order, number ending 1061. It appears at the bottom of the screen. But we also need to verify that. We do so by checking the EKKO table for new purchase order items numbered 1061. Check that the quantity and price match. We do this by opening the EKKO and EKPO tables. Again, this shows the details of our purchase order. You'll notice that finding new purchase orders and items is a lengthy process, and it's necessary to remember complex names and open multiple tables. Let's note down purchase order 1061. We'll see that later in the visualizations. With the new PO created in SAP, let's look at the next stage in our process and configuring the 5-tran connector. Here we've used an SSH tunnel to connect to SAP. Here we have SAP_ADLS_data_21st of May, which sends SAP data to Azure ADLS Gen 2. The Schema tab displays all the SAP abbreviated table names with a handy description, while the Setup tab has connection details and a sync frequency of 6 hours. Let's trigger a manual sync to capture the newly added purchase order in Azure Gen 2 storage. In ADLS Gen 2, you'll find a folder with the connector name _SAP HANA DB appended, containing synced tables as Parquet files. Note the technical names here. We've loaded the data into Azure using 5-tran and will now use Databricks to power the transformations. We do this to ensure there is no additional load on the SAP instance. To make this an extensible and repeatable process, we've used a GUI-based ELT tool, Prophecy, to build these transformations. We'll trigger the job manually, and you'll see the job details with step-by-step progress. After a short time, the job completes. Let's take a look at the dashboard to see how the data flows. The bronze layer now shows one new record, as we're using ADLS Gen 2 as the location for bronze table storage. Looking at the pipelines, you see that we have two: PL_SAP_silver and PL_SAP_gold. Refreshing the dashboard shows updated counts for silver and gold layers, reflecting the new purchase order. Checking the bronze layer data for PO1061, we type the order number, then click outside the box to view details. As shown, the new purchase order has synced from SAP to bronze layer, though the names remain in non-readable formats. In the silver layer, technical names are mapped to business names, making data easier to read and perform analytics. In the gold layer, we further curated the data with structured business objects like BO_purchase_order and BO_invoice. This is then presented in a final dashboard displaying business metrics such as the number of purchase quantities, the dollar value of purchase totals, pending quantities, and more. Lastly, you'll note that the new purchase order summary report shows PO1061 with one item, exactly as we would expect. We've talked about blue pills and red pills, but the answer is a combination of both. This blue and red pill is not about migration, but replication. The replication demo we've shown advocates a streamlined data process, one that's invisible to users, places no load on ERP systems, and transforms data to insights in near real time. We've enjoyed building it. We hope you enjoyed watching it. We'll leave you with a choice. Over to you, Morpheus.